Well, let's look at a simple probability problem where part A is just regular probability and part B will be a conditional probability. We have two different calculus classes, Class 1 and Class 2, and they all take the same exam. Classes 1 and 2 have 35 students and 25 students respectively. So, two different classes. Class 1, I sometimes put in parentheses the number of elements in Class 1 in this set, which would be 35. And Class 2 has a total of 25 students. And then a total of 14 students make an A on the exam. 5 of them from Class 1, 9 of them from Class 2. So I could do this. I could say I'm going to use the same letter in both of these. The A students, 5 of the A students are in this class, and 9 of the A students are in this class. So of the 14 students that got A's, we have 5 here, 9 here, which means what? Well, how many are outside of this circle A? If the whole circle adds up to 35, because that's Class 1, we'd have 30 out here that did not get an A. And we would have 25 minus 9. We'd have 16 out here that did not get an A. So that picture, we should be able to answer all the questions from this picture right here. Part A. If an exam paper is selected at random from all of the papers, you don't know which group it came from, which class, you don't know the grade or anything. One exam paper is selected at random from all the papers. What's the probability that it is an A paper? Well, it's the probability of A. I'm going to use A as, again, I'm being a little informal here. A is the probability that a randomly selected paper is an A. Well, we have to say it's the number of elements in that set over the number of elements in the sample space. What is that? Well, let's do the denominator first. How many are in the sample space? The total number of test papers is, there's 1 per student, and there are 35 plus 25 students. So that means there are 60 test papers, and we're randomly choosing one. And we want to know how many of those 60 papers are A's. And we already know that, it's 14. It's the 5 and the 9 for 14. And we could reduce that, but I'll just leave it there, as the probability of A is 14 over 60. Now then, if that's the probability that it is an A paper, what is the probability that it's not an A paper? That would be the probability of A complement. It is not an A paper. It's not in the set of A papers. And a couple ways we could write that. We know that it's 1 minus the probability that it was an A paper. Okay, so this is 1 minus 14 over 60, which is 60 over 60 minus 14 over 60. All I did is write 1 as we're having a common denominator of 60, so 1 is 60 over 60. 60, now we have a common denominator. 60 minus 14 is 46 over 60. And we could reduce that as well, but I intentionally didn't, just to make it obvious that 14 over 60 plus 46 over 60 gives you 60 over 60, which is 1, because every paper is either in the set A or in A complement. Okay, now on to some conditional probability. A test paper is selected at random, so this picture up here still works for this problem. A test paper is selected at random. If it is known that the paper is from Class 1, so that's some additional information given to us, then what is the probability that it's an A paper? So I'm going to write that like the probability of an A paper given that it's from Class 1. Again, I'm being a little bit informal here. I define the event A as being the event that the paper that is selected is an A. And this 1, or I, it looks like capital I, Roman numeral 1, this is the event that the randomly selected paper is from class 1. So, given that it's from class 1, we know that we're dealing only with this circle. Okay, this one did not occur, so this one, it's as if this one doesn't exist anymore for this problem. So what is the probability of A given that it's from this class? Well, it's simply the number of elements in the set A, inside, it's inside this I circle, 5 out of 35. It's like our sample space went from 60, both of these circles, 35 and 25, to simply being 35 possibilities. And 5 of the possibilities are A papers. So it'll be 5 over 35, which of course reduces to 1/7, but I kind of like to keep them this way because the denominators in this one were 60, and let's see what the denominator is for the next one. It'll be different because this time, what if the paper came from class 2? So what I'm looking for in this case is the probability of an A paper given that the paper came from class number 2. So now, if we're told that the randomly selected paper came from class number 2, this one will pretend like it doesn't exist because we know that it was taken from this set. And there are 9 A's in this set, so 9 over, or 9 out of 25 would be the probability. 9 out of 25. So that's a simple conditional probability problem. And once again, I'm going to remind us later also, if you can draw a picture, this is like a Venn diagram. If you can draw a picture of the sets and write the quantities in all of the circles and everywhere, it makes life very easy for answering any type of question.